In this video, we'll look at the Aufbau principle. On my previous video, we looked at electron configuration. So electron configuration is represented by means of energy level diagrams or Aufbau diagrams. We have several important rules for assigning the electrons to orbitals. You have to get used to the rules because we're still going to have so many rules. In science, we have so many rules, so you have to get used to the rules. What are the rules? We use circles or squares to represent orbitals, and we use arrows to represent electrons in the orbitals. Let's look at Pauli's exclusion principle. It states that an orbital can accommodate a maximum of 2 electrons with opposite spin. The opposite arrow directions indicate the opposite spin. These are the two ways that you can write your arrows or represent your electrons using arrows. If an orbital has 2 electrons, we say that it is full and we call the electrons an electron pair. But if only 1 electron occurs in an orbital, we call it an unpaired electron or half-filled orbital. So if you get an orbital like that one, with just 1 electron, then it is an unpaired electron or a half-filled orbital. The first energy level only has one s orbital, so it doesn't have any p orbital, it just has an s orbital. The second energy level has 1s and 3p orbitals. The third energy level has 1s, 3p, and 5d orbitals. The fourth energy level has 1s, 3p, 5d, and 7f orbitals. But for grade 10, we're going to only do from 1s to 4s orbitals. We're not going to get to 4p, 4d, or 4f. No, we're not gonna go that far. Maybe 4p, yes, but not as far as 4d. The name of the orbital tells us the number of the energy level involved and the type of orbital. For example, a 2p orbital refers to a p orbital in the second energy level. Electrons fill orbitals with the lowest energy first in order to obtain the lowest or most stable energy state. So the order of filling is 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. We're not going to go as far as 3d. Hund's rule. It states that when more than one of the same type of orbital are available, for example 3 orbitals, each orbital first gains 1 electron before it gains a second electron to form an electron pair. Remember we said that p orbitals, we have 3 p orbitals, so if you have 4 electrons going to your p orbitals, you're gonna first fill your px orbital and then fill your py orbital with another electron and then fill your pz orbital. Then you're gonna go back to your px and fill the other orbital. Remember, you have to have them in opposite directions. The maximum number of electrons per energy level is indicated by the formula 2n to the exponent 2. This is what I'm talking about in this table below. We have the main energy levels n, number of orbitals, n to the exponent 2, and number of electrons indicated by 2n to the exponent 2. So for the first energy level, the number of orbitals is just 1, which is 1 to the exponent 2, which is 1. Then the number of electrons are 2. In the second energy level, we have 4 number of orbitals and 8 number of electrons. Third energy level, we have 9 number of orbitals and 18 number of electrons, etc. If a particular energy level contains its maximum number of electrons, it is a completely filled level. The highest energy level that contains electrons is called the outermost energy level. The electrons are called the valence electrons. So the electrons in the highest energy levels are your valence electrons. The levels under this level are the inner levels with inner electrons or core electrons. Figure 4.9 shows the positions of the first 10 orbitals of an atom on an energy diagram. This is as far as we're going to go. 4s is as far as we're going to go for grade 10. So you have 1s, 2s, 2p, that's the second main energy level, 3s, 3p, that's the third main energy level. And then we have 4s, 3d, but we're not going to go as far as 3d. These are the steps to drawing the Aufbau diagram. First, you determine the number of electrons the atom has. Remember, how do we get the number of electrons the atom has? You get that from the periodic table. It's just the number of protons the atom has, because in the periodic table we have neutral atoms. You fill the s orbital in the first energy level with the first 2 electrons. Then you fill the s orbital in the second energy level with the second 2 electrons. You put 1 electron in each of the 3 p orbitals in the second energy level. Which rule do you use there? You use Hund's rule. And then if there are still electrons remaining, you go back and place a second electron in each of the 2 p orbitals to complete the electron pairs. You carry on in this way through each of the successive energy levels until all the electrons have been drawn. Let us now look at examples for you to understand this better, because you really need to understand this. Our first example is for hydrogen. So hydrogen has only 1 electron. How are we going to represent this? That is how we're going to represent that. So hydrogen has only 1 electron and it is in the 1s orbital. So this is the Aufbau diagram for hydrogen. See, it's not that hard. It's not hard at all. And then we have carbon. Carbon has 6 number of electrons because it has 6 number of protons. How are we going to represent that? First, we write the first electron in the 1s orbital, and then we write the second electron in the 1s orbital to make sure that the first energy level is full. Then we write the next electron on the 2s orbital, and then the other electron on the 2s orbital. So the 2s orbital is now filled. What about the 2p orbital? We have 3 2p orbitals, so we're gonna fill the first one first with the 1 electron, and then the second one with the other electron. Now we have all our 6 electrons. If you count 1, 2, 3, 4, 5, 6, make sure you count your number of electrons, because you can make a mistake. So make sure you count your number of electrons. If you're not sure, remember carbon is in group 4, so its valency should be 4. So the second energy level should have 4 electrons in total. So you can count your number of electrons in the outermost energy level, which in this case is the second energy level. So our second energy level, which is 2s, both 2s and 2p, you count your number of electrons in 2s and in 2p. It's 1, 2 in 2s and 1, 2 in 2p. So you have 4. You have 4 electrons in the outermost energy level, which means that your answer is mostly correct because the valency for carbon is 4. Do not make that mistake of putting both your 2p electrons on the first orbital, on the first 2p orbital. Do not make that mistake. Make sure that you follow Paul's rule. Okay, then we move on to our last example, potassium. So potassium has 19 electrons because it has 19 protons. How are we going to present that? So we need to fill in 19 electrons. We fill in the 1s orbital first with the 2 electrons. we fill in the 2s orbital with the 2 electrons. Then we fill in the 1p orbital, fill in the other one and the other one. Then now we can go back to the first 2p orbital and put in the other electron, put in the other electron, put in the other electron. Remember, the electrons have to be in opposite directions to indicate the opposite spins. Then we fill in the 3s orbital. Then again the 3p orbital, 3p orbital, 3p orbital. Now we can go back and fill in again and again and again. Then we fill in the 4s orbital. Now again, if you're not sure if your answer is correct, you can always check your valence electrons. The outermost energy level here is the 4th energy level, and we only have 1 electron in the 4s orbital. If you go back to your periodic table, your potassium is in group 1, so its valency is +1, so its valency is 1, so it should have 1 electron on its outermost energy level. So you know that your answer is mostly correct. You just need to check that you have filled in your electrons correctly on the other orbitals, so they are in opposite spins, your electrons. That is it for this video. On the next video, we will look at electron configurations.